7.1 area of a region between two curves. Okay, so if we wanted to find the area between f and g, where the limits of integration are a and b, we're looking at this area in here. Okay, and how we would find that, first of all, we would find the area between the integral a and b of g of x dx, and then subtract from that the integral from a to b of, should be f of x minus the integral from a to b of g of x dx, which another way to write it would be down here. Okay. All right, so hopefully that makes sense. So we're going to use this guy quite a bit to find the area between two curves, or the integral from a to b of f of x dx minus the integral from a to b g of x dx. Those are the same thing. All right, so let's look at our first example. So we're going to try to find the area between these two curves. So area equals f of 0 to 1 of f of x, which is x squared plus 2 dx, minus the integral from 0 to 1 of g of x, which is negative x dx. Another way we can write this would be the integral from 0 to 1 x squared plus 2, and this would be plus x dx. Now we can find the antiderivative, so this would be x cubed over 3 plus 2x plus x squared over 2. And we're going to evaluate this between 0 and 1. So when I plug 1 in to this antiderivative, it's going to be 1/3 plus 2 plus 1/2 minus 0. So if I plug 0 in all those, that would be 0. So let's see, the common denominator is 6. So this would be 2. This is 6. This would be 12. And if this is 6, this is going to be 3. So this would be 17 over 6. I guess units squared. That would be the area. Let's take a look at another one. Find the area between the curves here. So this time I'll do the area equals the integral. This goes out at -2. This goes out to 1, so it's from -2 to 1. The top function here is this guy here, so this is going to be 2 minus x squared dx minus the integral from -2 to 1. And then the bottom function here is x dx. So then I can write this, the integral from -2 to 1, 2 minus x squared minus x dx. Now I can find the antiderivative. So the antiderivative of 2 is going to be 2x minus The antiderivative of x squared would be x cubed over 3. The antiderivative of x is going to be x squared over 2. And again, we're going to evaluate this from -2 to 1. So first of all, when we plug in 1 throughout here, this would be 2 minus 1/3 minus 1/2 minus, when we plug in -2, this is going to be -4 minus, this is going to be -8/3 minus, or no, it's, yeah, and this would be 4 over 2, which is 2. So let's see, now I have 2 minus 1/3 minus 1/2 plus 4, that's positive, minus, that's positive. So now 2 plus 4 plus 2 is 8. This is going to be -9/3 minus 1/2. And this would be 3 minus 1/2. That's going to be, so this is going to be 4.5 units squared. All right, let's try one more of these. This one's pretty tough, just because it's trig. It's not ridiculously tough, but somewhat tough. We don't know what these limits of integration are here. We do know that to find the area in there, it's going to be, let's see, this one is sine, so it's going to be from blank to blank, limits of integration, sine of x dx, minus limits of integration, blank to blank. We got to find those. And then this is going to be cosine x dx. So we got to figure out where cosine of x is equal to sine of x. So first of all, let's do sine of x equals cosine x. We could divide both sides by cosine x. So this is going to be tangent of x equals 1. Where let's see, tangent, the inverse tangent of 1 equals x. I don't think that's going to help us. We could think of this as being opposite over adjacent. This could also be -1 over -1. Or you could use the Pythagorean theorem. Or we could look at it this way. Okay, one of the triangles would look like this, where this is angle x. The other triangle would look like this, where this is angle x. So if this is 1 and this is 1, this is going to be square root of 2, which means this angle here would have to be 45 degrees, or pi over 4. This would be 1, 2, 3, 4, 5. So to find this measure here, Okay. This would be 1 pi over 4. This would be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So the other one is going to be 5 pi over 4. So that's where they intersect at. So now up here we have pi over 4 and 5 pi over 4. So let's see here. We know that the derivative of sine is cosine, and we know the derivative of cosine of x is negative sine of x. So when we're going the opposite way, this is going to be the antiderivative of sine is going to be negative cosine x, minus the derivative of cosine would be sine of x. And we're going to evaluate this from pi fourths to 5 pi over 4. And then let's see here. We can factor out the negative 1. This is going to be cosine of 5 pi over 4 plus sine pi over 4 minus cosine, that should be 5 pi over 4. Cosine pi over 4 plus sine pi over 4 so let's see here. So cosine here would be adjacent over hypotenuse, so this is going to be 1 over the square root of 2. Oh, no. This is going to be over here, actually. So this is going to be negative 1 over the square root of 2 plus negative 1 over the square root of 2 minus, this would be 1 over the square root of 2 plus 1 over the square root of 2. So let's see, this negative 1 multiplied all the way through here, this is going to become positive. This would become positive. So we're getting 4 over the square root of 2. Rationalize this. So we're going to get 4 over the square root of 2 over 2, which is 2 square roots of 2. Units squared.